Hi, I'm John, and this is my video about Kubernetes and Azure Kubernetes services. So in this video, I'm going to be giving a brief overview of Kubernetes and Azure Kubernetes services. We're going to start by exploring containers and what containers are, how they compare to more traditional approaches such as virtual machines. We're then going to dive more into Kubernetes and what Kubernetes adds to containers and the benefits that it can provide. We're going to then dive more into the Kubernetes architecture and some of the key components of Kubernetes and what they do. And finally, we're going to explore Azure Kubernetes Services, which is Microsoft Azure's Kubernetes managed service offering. So let's start by exploring containers. So to give a bit of a history, we've had different methods and capabilities and advancements over the years on how we can run our application. Traditionally, it was commonplace and mainstream in the 1990s and the 2000s for us to have physical servers running in our server room or data center, and on top of the physical server, we would install the operating system, which would be Windows or Linux. And on top of the operating system, we would install our application. One physical machine was dedicated to one application. If the business then wanted to add another application, they would need to procure new hardware, a physical server, install the operating system on that physical server, and then install the application on top of that. And then we would have two physical servers for two different applications. This led us then on to the 2010s when we had a generational leap in the way that we could run our applications. And this was with the introduction of virtualization and virtual machines. And virtual machines enabled us to virtualize hardware on top of our physical hardware. And it meant that we could create a virtual computer and multiple virtual computers on top of the same physical server. And for all intents and purposes, inside the guest operating system of those virtual computers, they acted exactly as a physical server would. But they provided us with a layer of segregation and isolation between those guest operating systems, therefore allowing us to run multiple applications on separate virtual machines on the same piece of hardware. So this then leads us to containers, and containers provide us with another level of isolation and virtualization. Whereas before, virtual machines virtualize the hardware, containers virtualize the operating system, and they allow us to run multiple applications on top of the same operating system, which is typically the same virtual machine, in complete isolation. So we can have one container for one application that can interact with the OS, and it shares the kernel with another container, but they don't have the same access to the same storage, the same processes, they can't communicate directly, and they're segregated entirely. So what we can do with containers is we can define a lightweight, standalone and executable software package. So if we take, for example, Docker, we have a Docker file, and in that Docker file we can define the mechanism for building a container and all the components and dependencies that it needs. We build the container, and then we can deploy that container on top of a guest operating system, and then we can deploy another container alongside it. So now that we understand a bit more about containers and how it isolates and allows us to run multiple applications on the same OS in isolation, we can now explore Kubernetes services. And Kubernetes services is an open source container orchestration platform. So one of the issues that we would have with containers, especially when we're looking at a microservices architecture and we're trying to break down our application into multiple smaller pieces, i.e. containers that can be scaled independently, is we could potentially have hundreds or thousands of these containers that we need to run. And if we're trying to run each of them individually and managing them ourselves and connectivity, load balancing, it starts to become very complicated with all those small units. And this is what Kubernetes can do for us. So it can manage the networking, deploying our containers, scaling, and self-healing as well. And this is why it's known as an container orchestration platform. And Kubernetes is heavily associated with a microservices architecture. So microservices, as I mentioned, is the architecture whereby we take the same application and we break down into multiple pieces, into multiple containers in this example, and then we can run it on Kubernetes. And Kubernetes can then scale individual units of the application. So why would we use Kubernetes? Well, one of the big benefits of Kubernetes is avoiding vendor lock-in. So we can use Kubernetes on many of the different clouds like AWS, GCP, Microsoft Azure. We can also deploy our own Kubernetes cluster on premises if we wanted to. And inside the Kubernetes, the configuration of Kubernetes, the networking components, regardless of where you're running Kubernetes, all of these things are the same. And this enables us to avoid vendor lock-in. If we take, for example, a more native service on AWS, such as some of the PaaS services which are specific to AWS, a lot of the configuration and the way it's set up and how we get it to work with our application is specific to that platform. If we then wanted to adopt Microsoft Azure or Google Cloud Platform, we would need to use their alternative native service, and then we would need to refactor the application and stuff like that. So it'd be a lot harder to move between cloud providers. Kubernetes is the same on each cloud provider, so it reduces the friction to move and reduces the vendor lock-in if required. It then takes care of replication, self-healing, and rolling updates. So, say for example, updating our application, we have one of our application components and we've got a new version of it. We can deploy it, and Kubernetes will take care of updating our containers in a way that won't affect traffic or cause downtime. We then have resource efficiency compared to traditional virtualization. So if we think about more like virtual machines, we give a virtual machine 8 CPUs, 16 gig of RAM, and whether it requires that or not, it's going to utilize it. So with Kubernetes and our containers, it can move our containers between these different nodes to ensure efficient use of the resources we've got available. It's also open source, got a mature ecosystem and strong community support. So Kubernetes is widely adopted, trusted by enterprises, and widely understood by the community and due to its wide adoption. So this can make things easier if we have issues. It's typically going to be someone that's probably had that issue before or something similar that can help us. It's built for microservices. So as I said, very supportive of a microservices architecture. It also provides capability like RBAC, network policies, and secrets management built in. So typically going to need secrets for our applications, and it's got a built-in mechanism that we can use. So now I just want to run through a typical process that we might follow to deploy a new application to Kubernetes. So we're going to take the example of us already having a Kubernetes cluster, already running applications and containers on top of that cluster, and now we want to deploy a new application that we've developed alongside those other applications. So what we would do first is write the application code as we normally would on our machine, and then we commit it up to our Git repository. We then follow whatever process we have for getting our code into main, whether that's a pull request, approval from senior developers, and whatever we've got in our branch policies and our procedures. when we merge it into main, a CI process might be triggered that automates tests. And once all those tests complete and it's been approved with any gates or manual approvals, the container is pushed to a container registry. We would then need to prepare the manifest files, which is a YAML file that allows us to describe the application deployment and the use of Kubernetes components, such as pods, deployments, and services. So I'm going to get into pods more deeply in a second and more of those components. But ultimately, it's a YAML file specific to Kubernetes that tells Kubernetes how to deploy this application. We then use the CD tool would then pull the manifest for the Kubernetes, and it would connect to Kubernetes and apply the manifest. And finally, after that's been applied, Kubernetes would pull our container from the registry as per what's in the manifest and deploy the application. So now I want to get a bit more into the more specific components of the AKS and what they do. So we're going to look specifically at pods as a key component of Kubernetes clusters. In the next slide, I'm going to get into more of the other components and give just a bit of a high-level overview of what they are. So with regards to pods, pods are the smallest deployable unit on Kubernetes. So they are kind of reflective of an application. Typically, a pod would represent one application. But it can contain multiple containers. So it's not one pod to one container. It's a pod can have multiple containers, but typically a best practice is to use a pod for an application and the containers. So this might be just one container if that's all we have for our application, or it could be the main container for that application or service, and then a supporting container that provides some additional functionality such as logging or integration with something we can deploy within the pod. So the virtual network assigns each pod an IP address, which is used to communicate between containers inside the Kubernetes cluster. So Kubernetes has its own internal network, virtual network, and all of the containers and i.e. pods are connected to the virtual network, and each pod has its own IP address. Now these pods IP addresses are dynamic, so if one pod was to fail and get destroyed and redeployed, it would potentially come up with a different IP address, which isn't what we want, because we need a consistent permanent IP address for connectivity and features around the application. So this is where services come in, and we place a service in front of a group of pods or pod that represents our application or service. So we can see as an example in the bottom right here, we have the web service, and then below the web service we've got 5 pods. So all these pods would be the same application, and the service here would have its own IP address. The difference is between that IP address and the IP address on the pod directly is this will not change. If the pod fails and gets spun back up, it would then reinitialize the service and it would begin receiving traffic again. So we're not going to have issues from connectivity dropping out and a new IP address coming up and the issues that can cause, because we've got that consistent service in front. This service also provides load balancing between the pods. So we've got 5 pods here. These 5 pods could be deployed across different nodes for high availability, and the service would load balance to them. If one pod goes down, it will continue sending traffic to the rest, so it's highly available. So let's take a closer look at the Kubernetes architecture and some of the fundamental roles. So over here on the left, we've got the control plane, and this encompasses various different roles that are responsible for managing the Kubernetes cluster and coordinating our containers across our nodes. We have the control manager, and this keeps track of what is happening in the cluster. We've got the API server, and this is the entry point to the cluster. We've got the kubelet and the kproxy components that communicate with the API cluster. We've also, as administrators and users, got the ability to interact with the Kubernetes cluster via a CLI and an API, and this encompasses or uses the API role. We then have the scheduler, and this places pods based on workload and resources on each node. So you can see here we've got 3 different nodes, which would typically be 3 different virtual machines. And Kubernetes will spread out our containers and pods across these 3 nodes for a high availability. But it makes some decisions of how to place the containers and which node to use based on resources, utilization, how busy those nodes are, and this is what the scheduler does. We've then got etcd, and this holds the current state of the cluster with status of each node and container. And if the cluster has an issue, we could potentially use this to restore the state of the cluster at a later date. We then have nodes, and this is where the applications are running. Each runs pods containing our containers, and as I mentioned, the containers are spread out across these nodes. Each node has a kubelet node agent and the Kubernetes process, and this is the Kubernetes process that manages node activities. Finally, we've got the virtual network, which I mentioned in the last slide. This enables worker nodes and the master nodes to talk to each other and create one unified machine. So then let's take a closer look at Azure Kubernetes Services. So Azure Kubernetes Services is Microsoft Azure's managed service offering for Kubernetes. So let's begin by looking at some of the disadvantages we might have if we use a Kubernetes cluster on premises. So it requires a very specific skill set, and it's a very deeply technical role in setting up a Kubernetes cluster. There's a lot of components of Kubernetes to understand, and with Kubernetes on premises, you need to configure a lot of these yourself, and it requires skills and experience to configure the on-premises Kubernetes cluster. It requires manual installation, configuration, master and worker nodes, networking, storage, and other components. Patching, upgrading, and updating is manual. It can be time-consuming, and it can require planning to avoid downtime. So we're taking full ownership of all of the components of Kubernetes and are responsible for updating them. Scaling may require procurement and configuration of new hardware. So in the nature of Kubernetes and our small units, our pods, Kubernetes is scalable by nature in the context of the application. The problem that we have with on-premises is we can hit a hardware limit where we can't scale any further. And this is one of the downsides of on-premises, that we need to plan ahead for new hardware. If we want the ability to scale up dramatically to meet high demand at a specific time, we need to have that hardware, even if that hardware is not going to be used 90% of the time, because there's not a scale in demand 90% of the time. HA and DR would require advanced planning, additional infrastructure and configuration, so it could require separate data centers, fast internet connections, and it also typically requires capital expenditure. As with many on-premises solutions, typically they require us to foot the bill early on for all the hardware, installation, configuration, and then over time they have a lower operational costs. So then what is AKS? Well, AKS is a managed service offering for Azure Kubernetes, and it allows you to spin up a Kubernetes cluster very quickly in comparison to an on-premises environment. And Azure offloads much of the operational overhead, maintenance, and technical effort required to manage the cluster. It provides integration with services such as Azure monitoring, logging, networking, security, and identity. So if we take, for example, identity, we've got Azure Active Directory, which is the core identity service in Azure and Microsoft 365, and we can integrate Kubernetes cluster with it. So we can use our on-premises Active Directory credentials or our Microsoft 365 credentials to access Kubernetes cluster. And as I mentioned, it offloads much of the operational overhead off to Azure, reducing the effort required to manage the Kubernetes cluster. So then finally, we've got a side-by-side comparison of Kubernetes and Azure Kubernetes services. So first we have infrastructure setup and configuration. So with Kubernetes, as I mentioned, the configuration of Kubernetes can be complex. It can require manual installation and configuration. AKS and the deployment of Kubernetes cluster with AKS is automated and abstracted for a user. So Azure deployment process takes care of a lot of the configuration that we typically need to do for an on-premises cluster. We can optionally add our own bespoke configurations to sway away from the defaults, and typically we would do this in an enterprise setting. For more complex applications, we'll certainly need to make tweaks to the configuration and get it right for our scenario. But this is not in comparison to on-premises and procuring hardware, installing and building the components of Kubernetes from scratch. Then we've got maintenance and upgrades, so we're taking full ownership of maintenance and upgrades with an on-premises Kubernetes cluster. With AKS, Azure patches and upgrades to master nodes for us. In terms of scalability, and it's similar as well for HA, so for the next two lines here, if we want to scale or if we want to add HA and DR capabilities such as multi-region failover, this can be difficult on premises. We need to have the infrastructure in place, potentially fast connections, hardware, and the ability to scale up in different places, meaning we need additional hardware. This is different from Azure Kubernetes services, which in contrast, we can scale up in Azure, providing that we're happy to pay the cost of it. We can scale up very quickly. There's virtually unlimited hardware or resource power, compute power available to us to use if we need to. We then have networking and security, and the same for monitoring and logging. On-premises, it's all manual configuration and can be quite complex and requires specific skills, whereas with Azure, for networking, the components are pre-configured, they work outside the box. We can do further configurations and integrations with different, so for example, Azure VNets, we can integrate it there so we can get on-premises connectivity and stuff, but this is simplified when compared to on-premises. In terms of monitoring and logging, in Azure, we've got seamless integration with Azure platform tools. Further configuration may be required for third-party integrations, though. And then in terms of cost, as I mentioned previously, with an on-premises cluster, we're making a big upfront commitment by spending capital, procuring hardware, and the costs associated with delivering the project upfront. So we're making a big capital expenditure upfront. If we were to decide that Kubernetes wasn't right for us, it's very likely that some money would be wasted in that process. This is in contrast with Azure and the nature of cloud in general. We've got operational expenditure. We are charged for what we use, when we use it, and at the scale that we use it. And this means that if we've in this scenario, if we found out that Kubernetes wasn't right for us, we could switch it off and remove it, and there would be no further cost. We would only have paid for what we would have used during the testing period and the time that we've had it deployed. Finally, we've got skill set and manpower, and both on-premises Kubernetes and Azure Kubernetes services require specific skill sets. However, with a Kubernetes cluster, it certainly requires more technical depth than what it does on Azure, due to the way that Azure takes care of many of the underlying components of Kubernetes for us. So in an on-premises cluster, we're going to need deep understanding of the different components so that we can set them up from scratch, whereas Azure Kubernetes cluster, there's still skills required, of course, around how a cluster works and how to configure the deployment of our applications to be efficient and work the way that we need it. But this is not in comparison to Kubernetes on-premises. That concludes my presentation on Kubernetes and AKS. Thank you for watching.